Hello, everyone. In today's lesson, we will learn about the automatic measurement and dimensional evaluation of CNC lathe parts, automatic measurement of rotor features based on star probes. Next, we will cover the following topics. By the end of this session, you should be proficient in using a star probe for the automatic measurement of rotor features on CNC lathe parts. You will be able to accurately evaluate the dimensional accuracy and shape errors of parts based on the measurement results. Now, let's begin with dimensional measurement analysis. The primary surfaces of CNC lathe parts are the outer cylinder and inner hole surfaces. During measurement, we generally follow a left-to-right or top-to-bottom sequence. It's essential to pay attention to the movement path of the starpoint probe, especially when measuring features such as grooves with limited clearance or interference between the probe and the measured cylinder should be avoided. In this task, we will use various functions, including automatic plane measurement, arc movement addition, and creation of common reference points. Now, let's dive into practical hands-on learning. Next, we will look at the automatic measurement features. The measurement sequence generally follows a left-to-right or top-to-bottom order. Since the measuring plane PLN1 is the reference plane PLN1B2, it does not need to be measured again. Now, let's measure cylinder CYL1. Using the automatic cylinder command, rename it as CYL1, set the center to 0, 0, 0. The surface normal to 0, -1, 0, and the angle to 1, 0, 0. Then select the outer cylinder with a diameter of 66 and a length of -10. Enable the arc movement switch and the show contact point switch. Click Contact Path Properties, set the number of points per layer to 6, the depth to 2, the end depth to 2, and the number of measurement layers to 3. Click Create. Similarly, we will automatically measure cylinder 2. Change the center to 0, 180, rename it as CYL2. Select an outer cylinder with a diameter of 76 and a length of -8. Enable arc movement switch and show contact point switch. Set contact path properties to 6 points per layer, with each layer having a depth of 2, ending depth of 2, and 3 measurement layers. Click Create. Next, let's proceed to automatically measure plane PLN2. This plane is constructed by measuring a series of vector points. The specific steps are as follows. First, select the probe T2A0B0 and set the working plane to the negative y-axis. Enable the automatic vector point command. Switch to polar coordinates, rename it as PNT1. Set R to 29, A to 210, and H to -33. With the surface normal as 0, -1, 0. Then click Create. Using the same method, measure the second vector point PNT2 with a change to 180 and the vector 0, -1, 0. Then click Create. Using the same method, measure PNT3 with a set to 150 and the surface normal 0, -1, 0. Click Create and close. Now, switch the probe to T1A0B0. Following the same procedure, measure the next 3 vector points. PNT4, 120 is 0, -1 is 0, create. PNT5, 90, -1 is 0, create. PNT6, 60, -1, 0, create, and close. Now, change the probe to T4A0B0. Using the same method, measure vector points 7, 8, and 9. PNT7, 30 is 0, -1 is 0, create. PNT8, 0, -1 is 0, create. PNT9, -30 is 0, -1 is 0. Create, and then close. Review the 9 vector points. Now, we will use the 9 collected vector points to construct the plane feature. Click Insert Feature Construct Plane, which will open the Construct Plane tab. Then, sequentially select the points PNT1 to PNT9. Rename it as PLN1-2. Check the options for Best Fit and Least Squares method, and then click Create. This will create Plane 2. Since Plane 3 is symmetrical to Plane 2, all parameters remain the same except for the y-coordinate and the plane normal vector. Next, we will try to use a plane measurement command to complete the measurement of multiple points. The steps are as follows. In program mode, collect 9 measurement points on plane 3 and press the End key to finish the measurement. The specific steps are as follows. In program mode, collect the 9 points on plane 3. Once the points are collected, press the End key to create plane 3 and rename it as PLN3. Next, we will assign probes to the 9 measurement points. Insert a probe switch command before every 3 measurement points. The specific method is as follows. Place the cursor after the measurement of the plane, change the probe to T2A0B0, then move the cursor after the 3rd measurement point and switch the probe to T1A0B0. After the 6th measurement point, switch the probe to T4A0B0. Remember to add movement points at appropriate positions to avoid interference during measurement. Next, let's proceed with the automatic measurement of cylinder CYL3. Using the automatic cylinder command, change the center coordinates to 0, 78, 0. The surface normal to 0, -1, 0, and set the angle to 100. Select the outer cylinder with a diameter of 94 and a length of -10. Enable arc movement switch and show contact point switch. Rename it as CYL3 and click Create. For the 4th cylinder, follow the same measurement method. Rename it as CYL4, set the center to 0, 94, 0. And the length to -6. Enable arc movement switch and show contact point switch. Set contact path properties to 6 points per layer with a depth of 2, ending depth of 2, and 3 measurement layers. Change the depth to 1 and the ending depth to 1. Click Create and close. Through this lesson, we have gained an in-depth understanding of the method and steps for the automatic measurement of rotor features based on star probes. We have learned to apply automatic plane measurement, add arc movement, and create common reference points. Through practical exercises, we have strengthened our understanding of the measurement process. I hope everyone can apply these knowledge and skills in your future real-world scenarios and continue to improve your professional abilities. At the same time, I also encourage you to stay engaged with new technologies and methods, contributing to the development and advancement of CNC machining technology.